All right. Good morning, everyone, and happy Valentine's Day. This is the ACA note for today. Our warm-up is evaluating. Remember, evaluate is just a fancy word for solve the expression. Remember last week when we did this, what did we do first before we solved it? Yes, Kennedy? Very good. Substituted the letters for the numbers. What do you predict I need to be very careful with on these two parts? What do you think could be an issue with Mom?
Like people forget.
What?
You forget to miss letters and numbers.
Maybe that, but
Like they'll just put the numbers and forget to do the multiplication.
very good. These numbers A and B and then A and C, they're getting multiplied. So when you substitute it in, I'll do this first one so that you don't forget. So A is 4 and B is 12. So I'm going to do 4 times 12. You can also put one of them in parentheses plus A times C, so 4 times 3. Okay? So either way, you want to write it, substitute, and then solve. I'll give y'all a few minutes. Pause and play when you're ready. All right, order of operations is always there. We just forget it sometimes. So in this first problem, what do I do first? Multiply. 4 times 12 is 48 plus 4 times 3. Am I done with my multiplication? No. So I need to do 4 times 3, which is, and 48 plus 12 is equal to 60. I think there was some math errors on that. Maybe people do get in their head when they should. Okay. Again, let's substitute before we solve. Can someone read me their new expression? Can someone read me, Lana, the new expression? Oh, we already did that one. This one. Can you substitute in for me? A was
4 minus 2 plus, times 4 times 6.
yeah, 4 plus 6. Yeah. Okay. So class, order of operations tells me to do what first? Grouping. Correct. So 4 plus 6 is 10. 4 minus 2 in parentheses 10. Now, I did look at a few tests, and this is where we had a few people make mistakes. What operations are still happening in this problem?
Multiplication
And subtraction. A lot of people either added or subtracted. They subtracted first before they multiplied. Okay? You have to be very meticulous, like very careful when you do this part. So I would next need to do one step. That 2 times 10 in class, that gives me 20. Now, what kind of answer am I going to have? A negative. That's why it'd be positive numbers, because you solved it out of order. A lot of y'all did 4 minus 2 first and then times the 10. Okay, when I subtract 4 minus 20, that is negative 16. Remember, you can rewrite this. If you don't like subtraction, you keep the first one and then change it. Okay, and that's another way to look at it. You think of the team who's winning, the negative team is winning by 16 points. Okay, we have to remember those little skills. All right, here we go. Little heads up for the week. We do still have a minor grade this week. We have that quiz. Now remember that quiz for y'all is on Wednesday, so not tomorrow, but the day after. That quiz is the magic one that serves as our retest. If you failed any tests or any of your quizzes, but do better on the quiz on Wednesday, maybe you've had time to settle in on some of the skills, you come to tutorials and remaster those things. That quiz on Wednesday can replace any failing grades up to a 70 if you do better on that quiz on Wednesday. Okay? With academics, it tends to be one of those game changers. Like, it helps a lot of y'all. Because y'all just need a little extra time to let that settle in. Imagine Math is also due on Wednesday for y'all. Remember that's how many points on your lowest quiz? 15. So make sure you're getting it done. Each lesson that you do is 5 points, okay? So you just have to do 3 lessons. Hopefully you've done at least 1, maybe 2, and you just need to rock through 1 more. Or you've already done it because you did the first. But Any questions? Again, things to keep in mind, that quiz on Wednesday is anything from this 6 weeks. So it could include a little bit of ratios, additive versus multiplicative, and then prime factorization, order of operations, distributive, properties, additive, associative, and commutative, that kind of stuff. Y'all good with that?
Yeah.
Okay, let's keep it moving. Give me a second real quick. All right, so what we're going to be talking about today is called simplifying expressions. And we sort of kind of talked about this in a loose term, but we're going to really just connect everything. Okay, simplifying expressions is like combining like terms with like terms. If you remember when we did distributive, Ms. Lytle said like if we had this 4 in parentheses 2 plus 4x, we said that we can't add those two things because that's like the popcorn and the soda. We don't want to combine these two things. We can only combine like things with like things, so like popcorn with popcorn and drinks with drinks. So that means anytime there's x's, we can combine x's with other x's. And then these are just called, when it doesn't have a letter with it, it's called constants with constants. And we'll model that so you can sort of visualize it. Okay? So we're given the expression negative 2x plus 3x plus 5 minus 1. Y'all with me on that one? Okay? So what they did is they modeled negative 2x are those two shaded in rectangles. 3x are the positive, the white ones. Are y'all good with that?
Yeah.
1, 2, 3. Okay, then because this guy doesn't have an x, they are just using the tiny little cube. So there's 1, 2, 3, 4, 5, and then minus 1 is also the same as a negative 1. Okay, then if y'all remember the counters at the beginning of the year, a positive and a negative give me a 0 pair. Okay, y'all remember that word, 0 pairs? It's a pair that adds up to 0. So we see that they've circled any 0 pairs, and let's see what we have left over. Let's start with my x's. Those are the long rectangles. How many x's do we have? 1 x. So you can either write 1x or just x. Either one is fine. You can write both ways. And then I have what else? 4. Are those positives or negatives? Positive. So you can put plus 4 or plus 4. Okay? This is technically the most correct, but that's what it was. I combined my like terms with like terms. Again, looking at my x's. Okay, looking at the x's, negative 2, positive 3. I have more positives. How many more? 1 more positive. And then looking at my constants, 5 minus 1 would give me 4. Okay, let's just do another one. On here, 7x plus 3x. First, let's talk about, are they like terms? Do they both look the same, sort of, kind of? Yes, they're both going to have those rectangles. Okay, I'm going to start with how many? 7. 1, 2, 3, 4, 5, 6. Okay, I tend to like to put an X inside each one of them. That way I know that sometimes my rectangles look like squares and then it's confusing. Okay, plus 3x. 1, 2, 3. Again, these are just the same thing. Ask yourself, are there any 0 pairs? No, because they're all positives. They're all positives. And therefore, I just counted up. In total, I have 10. Okay? I'll do one more, and then I'll let y'all do the last 2. Does that sound like a plan?
Yes.
Okay? Starting with negative 4x, I'm going to have rectangles or squares, positive or negative. Negative rectangle, so I'm going to start with 4 of those. 1, 2, 3, 4. They are rectangles because it says that an x is the rectangle.
Oh,
okay. So there's negative 4, so this is going to be a negative x, a negative x, a negative x, and a negative x. Sorry, it's a little hard to write x on this. Okay, so I've done this first term. Okay, then it says minus x. How can I model a minus x?
No.
Oh, you have a 1 positive.
It's not positive. Subtraction is the same thing as another negative x. Because remember, minus, to show minus, we just do a negative instead. Okay? And then plus 2. The 2 is going to be 2 rectangles or 2 squares. 2 squares, positive or negative? Positive. 2 positive little squares. Now combine like with like, x's with x's. Do I have any 0 pairs in those x's? No, because they're all negatives. How many do I have in total?
4.
I have 1, 2, 3, 4, 5. So negative 5x plus 2. Okay? Now, I want y'all to try out the next 2, model and then simplify. Okay, I'll give y'all a few minutes. Try it out. Take a risk. Do it. Pause and play when you're ready. All right, here we go. So, again, a helpful tool to know whether something is positive, thank you for not talking, whether something is positive or negative, is I tend to like break up my terms. I usually take the sign that's in front of it, so I'm going to do it on some of the ones that I've already solved. Okay, so like this first one, what I mean by breaking up my terms, I'm going to take the 2x and I'm going to circle it with a sign in front of it. This 3x, I'm going to take that sign in front of it, 5 with the sign in front, and 1 with the sign in front. Okay? Again, I combine like terms with like, so they both have x's. If I have negative 2 and positive 3, do I have more positives or negatives?
Negative.
If I have negative 2 and positive 3, I have more positives. How many more positives? 1 more positive x. Looking at the things without, I have positive 5 and negative 1. Do I have more positives or negatives? More positives. How many more positives? So a positive 4. And that matches my thing over there. Okay, let me do it again. I take the term with the sign in front of it. There's no sign in front, so that's implied that it's going to be positive, and then the positive 3x. I only have x's together. That makes 10x. Okay, let's do it one more time. 4x is going to take that sign in front. X is going to take the sign in front. 2 is going to take that sign in front. Do y'all see that? Okay. Like terms with like terms, so x's with x's. Negative 4 and negative x. Are there any 0 pairs? No, there's only negatives. There's not positives versus negatives. I only have negatives. In total, I have 5 negative x. Positive 2. Okay, this is sort of how to do it without a model. So let's keep going. So I want you on your paper to actually circle the term with the thing in front. So this 6x is going to be positive or negative?
Negative.
That 5x is going to be
Positive.
positive. That 3 is negative. And the 2 is positive. Let's model that. Okay? For the x's, are those rectangles or squares? Rectangles. So I'm going to start with negative 6. Again, I just show that they're negative, either by shading or by putting a negative. Okay, I've modeled this one for the 5x's. Squares or rectangles? Rectangles. 1, 2, 3, 4, 5. Do I have any 0 pairs with the x's? 5 0 pairs. Okay, what do I have left over? 1x, and it's a negative x. Okay, and then let's do the last bit. Again, these guys are on their own. They're the little squares because there's no x with them. Negative 3 is going to be 3 little ones, and I'm going to put a negative sign in them. Again, you could shade them. And then positive 2, you can put like a plus sign if that helps. Or you can leave them here. Do I have any 0 pairs?
Oh, yeah.
I've got 2 0 pairs, and left over I have a negative 1. Negative x minus 1. You could also write negative 1x minus 1, but this one is more correct. Yes, sir. Question? Okay. So again, looking at this, I combine like terms with like terms. X's with x's. Do I have more positives or negatives? Negatives. How many more negatives? Negative 1x. Or again, just a negative x. Looking at my constants, the things without a variable. I have more negatives. How many more negatives? 1 negative. Okay? All right, let's do that again. Try and circle the term with the thing in front of it. Y'all ready? Okay, that's 3x's positive, the 2x's, and the 7 is very good. Okay? It's negative. You take it with the sign in front of it. Modeling 3x's. 3, are those positive or negative? Again, we said they're positive, so we don't have to put anything. 2x's, those are positive. I'm positive with a positive. Okay, 7x's negative. 1, 2, 3, 4, 5, 6, 7. Again, those are negative. Okay, do I have more positives or negatives? Negative. How many 0 pairs can I make here?
5.
5 0 pairs. And I'm left with
Negative 2x.
negative 2x. Okay, so over here, again, you can combine your positives with your positives. That would give me 5x minus 7x, again, would give me negative 2x's. Okay, now, to spice it up just a little bit, and I don't know if this is necessarily spicing it up, but it's showing you a way you can check it. Okay, a way to check these answers every single time. What have we said that x means? It's an unknown value, right? Okay. What you can do, pause. What you can do is you can always check to see if your answer is correct by plugging a number in for x. So Ms. Final tends to put in just 2 for x. 0 and 1 aren't really friendly. 1 second, sorry guys. That's plus my recording. Okay. So what I'm going to do, and I'm just going to show you this. You don't have to, but it's encouraged. Is plugging in x for 2 on both of these things. Okay, and what you can do is you substitute it in and solve it, and you should get the same answer. So if I did 3, what's happening with 3 and x? They are getting multiplied. If I did 3 times 2 plus 2 times 2 minus 7 times 2, that should equal negative 2 times 2. Okay, again, if you're talking, you're missing part of the lesson, and it's rude and disrespectful. Please don't do that. In order of operation, what do I always have to do first? In this case, I can multiply. So with me, 3 times 2 is 6, plus 2 times 2 is 4, minus 7 times 2 is 14. Y'all with me so far? Now I can add left to right. 6 plus 4, 10, minus 14 would give me negative 4. If I did this correctly, I should get the same answer over here. Negative 2 times positive 2. Signs are different. Negative. What's it? 2 by 2? 4. If you simplify your expression, if you combine your like terms correctly, and you plug in a value, any value, you could put in x is 6, and you should still have matching answers. Okay? If you do it correctly, it should work every single time. Okay? So, let's just, that's sort of like the modeling of today's lesson. We're going to just do a little bit of notes, but that's basically it. Okay? Again, that's called simplifying expressions because it's getting all of the 0 pairs out of it. When addition or subtraction signs separate an algebraic expression into parts, each of those parts is called a term. And you sort of heard me say that. Each part is a term. Anytime there's an addition or subtraction, each of those separations is a term. The numerical factor of a term that contains a variable, so like here on this, the numerical factor, whenever it has a variable and a factor, so 3 and x, when it has a letter and a number, that number is called the coefficient. I don't know if I spelled that right, but I'm not worried about it. Everyone say the word coefficient? Coefficient. A term without a variable, so like this guy right here, a term without a variable is called a constant. The reason why it's called a constant is it doesn't matter what you put in for that variable, that 7 won't change because it's not going to be multiplied by that letter. It's a constant. Okay? And blank are terms that contain the same variables. like terms. Like terms. Like terms are terms that contain the same variable. So x, 2x, and 3x are all like terms because they all contain, they all have an x. So one more time. Like terms are, they contain the same variable. So x, 2x, and 3x are like terms because they all have x. Okay? So they gave us an example. Again, each time it's separated, the 3x is a term, 7 is a term, x is a term. Anytime it's separated, they are called terms. Like terms have the same variable. So x and 3x, the things in red up on my board, those are like terms. Why is 7 not a like term? Very good. Okay, and 7 is also called a constant because it does not have a letter with it. Okay, so that was an example that's done. Let's see if we can figure out these other things. So in this first box, it's pointing to the 4, and 2, and 9. All three of those are called terms. Okay, this box is just pointing to the 9 that is called my constant. And then be careful. The 4 and the 2, Jackson, they're not my constant. Again, they have letters. They are my coefficients. It's the letter. It's pointing, sorry, to the number when it has a letter. Coefficients. What operation is happening with a coefficient? It's multiplication because it's multiplying times that letter. You gotta be careful. All right. So, just practicing a little bit more, combining like terms, simplifying expressions. To simplify an algebraic expression, use properties to generate equivalent expression. Okay, if I have x plus x, think of the model. If I have x plus another x, in total I have 2x. I can add I can only add like terms. Negative 4 times 6x is going to be negative 24x. If you remember like the distributive, it's negative 4 groups of 6x. So that's saying I have 6x, 1, 2, 3, 4, 5, 6. But I have that how many times? 4 times. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. But that's only the 4 groups. I still need to do the negative. So right now I have 24 x's, but the opposite of that would be negative 24 x's.
Oh, so positive.
Okay. So two expressions are equivalent when the expressions have the same value, no matter what the value is substituted for x. If you put in 24,000 for x and solve both sides, you should still get the same answer. So negative 24x is equivalent to negative 4 times 6x. I would not ever plug in 1 or 0 as I've mentioned. Those are not a good idea to plug in for x. It's always good to do 2 or above, but keep it simple, so that's why I say 2. A lot of y'all can just do 2 like no other. Okay? So, looking at A, 3 times x would give me 3x. Okay? Times 11 would give me 33x. Again, I can multiply on my terms, I just can't add on my terms. X plus x plus x, 3x. Okay, and then C, we have to be careful. What are my like terms in C? Very good. And I'm going to do that thing where I circle it with the sign in front of it. So that 7 is positive, the 8 is, and the x is. Okay, I'm going to combine my like terms. 7x and x would give me 8x. Can I combine that 8 with it? No, because
I'm the like terms.
Because it's unlike. It doesn't have an x. One has an x, one does not. Popcorn and soda can't do it. Justin, I can live. You can be wrong. All right. How about y'all try? Oh, okay. Sorry, we haven't done one like this. Pause. Thank you. Okay, looking at this next one, x plus y. What are my like terms? X and x. So in total I have 2x plus y.
Or 1y, right?
You could put 1y, but you don't need to, Hudson. You don't need to. Okay. Over here, can I do x plus the y? No, because we don't know the values. But what would we do? We've learned we could do not just 4 times 2, but
4 times 8.
we're going to distribute. Oh, y'all remember that?
No.
So 8x
You
plus
need
4,
to,
right?
and remember we're recording. So 4 times 2x gives me 8x
plus
plus, thank you, plus,
4y.
very good. And again, I can't go any further because those are unlike terms. Go ahead and try ABC. Even if you're wrong, at least you're trying it out. Okay, pause and play when you're ready. All right, here we go. So starting in the parentheses says order of operation. Order of operation, so I'm going to do grouping first. Can I do 14y plus x?
No.
No, they're unlike terms. Now, can I like break the rules of order of operations and add outside?
No.
What did we learn about the properties? The order of addition, is this all addition? Yeah. Does the order of addition matter? It doesn't. Okay? So I can actually just add whatever I want to. So what two can I add together?
14y plus 22y.
Because they are called
Like
like terms. Very good. So 14y and 22y
36
would give me 36y plus x. How else could I write that because of the commutative property? Which one?
x plus 36.
Very good. Either one is totally correct.
Can it be like 24 and x plus 36?
Not on the problem. Okay? Next one. What are my like terms, Natalia? What do you think are my like terms in B? Very good. 3x and 2x. Again, if you want to get in that habit of circling the term with the sign in front of it, again, right now these are all additions, so they're sort of friendly, but when the title gets to subtraction, she wants to rock the socks off of it. Okay? So 3x and 2x, Natalia, what would you get there? You're adding them. 3x plus 2x would give me 5x, and then I'd be left with that 9y. Okay? Class, can I do the grouping?
Yeah.
I cannot because unlike terms. Instead, I can distribute 21x plus 7y. Ooh, yes, not just plus y. We have to distribute to everyone. Again, if Miss Lytle doesn't give everyone candy, I'll hear about it. So if you don't distribute that 7 to the y, you'll hear about it.
I have living.
All right. So now what I want you to do for the remainder of class, we still have about 10 minutes. You're going to simplify these expressions. If it helps you to model, can you model? Yes. Okay. Remember, it's very helpful to circle the term with a sign in front of it for when you combine them. I want to see those skills. Pause and play when you're ready. 2, 1. Okay, on this first one, do I have any 0 pairs? No, I have 8x. Circling the term with the thing in front of it. 8m and negative 5m. Do I have 0 pairs? Yes, and what do I have left over? 3m. Okay, circling it with the term in, sign in front. Negative 7, positive 4. I have 4. More negatives. How many more negatives? 3y. Okay, circling with the term and the sign in front. Do I have any 0 pairs? No, it's all positive. So 3, 2, and 7 gives me 12x. 5k, negative 8, positive 7. Are those all like terms? No, which one is unlike? Y'all just said two different things. Which one's the unlike term?
7.
The 7 because,
It's not
okay, so I can only do like with like. Positive 5 and negative 8 gives me 3 negatives, negative 3k, and then that plus 7. Okay, good. I like that vocab. Okay, what are my like terms? The x's with the x's, so Lana, how much do I have? 8x, very good. Positive 8 and negative 2, those are like terms. What am I left with? What kind of 6?
Negative 6.
The positive 6. Because there's more positives, right? So the positive 8 and negative 2, more positives. Negative 16p, positive 6, negative 2. P's with p's, that's going to be negative 18p. It's negatives with negatives. Okay, so I don't have any zero pairs. Plus 6, 12m, negative 7, positive 4. Positives with positives, that gives me 16m minus 7. And then the last bit, I have a total of 5y plus 2. The rest is your homework, guys. Please study.